Believe it or not, fractions do have important uses in the real world, and sometimes we need to reduce fractions. And if we're ever going to learn to do algebra efficiently, we have to understand the processes that we use with numbers, and it's very necessary in algebra to work with fractions if we're going to analyze anything using any kind of algebra, or at least in a lot of problems we're going to run into that. So let's say we want to reduce 48 over 252. Okay, well, if we write 48 and 252 as their prime factorizations, then we see that for 48 we've got 4 2's and a 3, and for 252 we've got 2 2's, 2 3's, and a 7. The most sensible way to reduce these numbers is to factor out anything that's in common between the numerator and denominator. And we see that we can rewrite the numerator as 2 times 2 times 3. Let's say we take these 2's and this 3 and put them out in front and leave us these 2's. The denominator, we do the same thing. We factor out 2 2's and a 3, leaving us a 3 and a 7. Now it's clear that what we factored out of the numerator and denominator is first place equal. What's taken out of the numerator is factored out of the denominator. And also that there's nothing more left that we can factor out of the numerator and denominator. We factored the maximum possible number out of the numerator and denominator. Okay, that number that we factored is divided by itself since we factored it out of both, so it just gives us 1. And then 2 times 2 over 3 times 7 is 4 over 21. And 4 over 21 doesn't reduce. It doesn't reduce, it can't possibly reduce because it doesn't have any prime factors in common between the numerator and denominator. 4 has no prime factors that are common to 21. We've factored out all the possible common prime factors from our original fraction, and when we factored those out, we divided them and got 1, and now we've got 4 over 21. Incidentally, I don't use the word cancellation unless I can help it. I simply find that people don't cancel correctly. There's all kinds of incorrect cancellation floating around out there, and I prefer to go back to the basic laws, but of course you will recognize what I did as a form of cancellation. Looks like the camera's a little crooked here. Okay. Now, the thing that we factored out, the 2 times 2 times 3, which is 12, is the largest divisor common to 48 and 252. We call that the greatest common divisor. And the greatest common divisor is what factorizations have in common. Okay? We've seen that there's we do have those numbers in common between numerator and denominator, and that there's no bigger number in common. The product of those three numbers is as big as it gets. So that what we have is indeed what we call the greatest common divisor of the numerator and the denominator. Now in the next clip we'll actually let's stick to this clip for a minute. Okay. Here's another question. What's the smallest number that's divisible by both 48 and 252? Now, since we're familiar with the 48 and 252, 48 is written this way, 252 written this way. Whatever number is a common multiple of both of these, any number that's a common multiple of both 48 and 252, well, it had better have a 2 in it because both 48 and 252 have a 2 in it. And it had better have a 3 in it because both 48 and 252 have 3's in it. And it better have a 7 in it because 252 has a 7, and 252 won't divide into that number unless that number has 7 as a factor. Now, what all does that number really have to have? Well, we see it has to have a 2, and it has to have a 3, and it has to have a 7. Is that going to be enough? Well, no, because 48 really requires 4 2's. 48 contains 4 2's as factors, so any greatest common, or any least common multiple or smallest number that's a multiple of both is going to have to contain 4 2's as factors. Otherwise, if we try to divide it by 48, we'll have some 2's left over that won't divide out. And let's see. The 4 2's that we get from 48 are going to be sufficient to take care of the 2 that we need for 252. In other words, if our multiple, our common multiple, has 4 2's in it, then we're not going to have any trouble out of the pair of 2's that we have in the 252. When we divide 252 into that number, the 2's will be taken care of. But we're also going to need a couple of 3's. We only need 1 3 for 48, but we need an extra one here. And we're going to need the 7, of course. So, turns out that our desired number must have 4 2's, otherwise 48 won't divide it. It must have 2 3's, otherwise the 252 won't go into it, and 1 7. Okay? Not only must it have those, but that's sufficient. That's enough. Well, our number, which we call our least common multiple, the smallest number that's a multiple of both, is the multiple of 4 2's, 2 3's, and a 7. And we'll note here how that works out. If we look at the prime factorization, if we've got 4 2's, 2 3's, and a 7, and try to divide it by 48, we'll be able to group these numbers, and we'll be able to group these numbers, divide these out. That gives us 1 times 21. So this number divided by 48 is 21. And if we do the same thing with (252), we'll be able to group all these numbers, turns out, with these numbers, and we'll end up with 2 times 2, or 4. Now we can multiply this number out, and I believe it's going to come out 1008, this numerator, so that 1008 will be, I'm sorry, 3008, and that can't be right. If I multiplied that correctly, probably not. I'm asserting that it's 3008, and when I multiplied it just now I got 1008. So I think that when I wrote this I made a mistake, and it should be 1008. Okay, so this clip has illustrated the process of finding a greatest common divisor, and it's what the prime factorization have in common. In this case would be 12, in the case of 48 and 252, and the least common multiple, which for those two numbers is 1008.